Hi dear students, this is Phanindra. I am faculty at MEDG. In this today lesson, I will going to explain you what is sensor and what is actuator and how these things are important to each field of engineering. So guys, next 10 to 15 minutes be with me, you will understand these things very clearly. And moreover, this section is important for mechanical students, EC students and electrical students and instrumentation students, irrespective of the branch of engineering. So let's get started. Now let us see what is sensor. But before defining what is sensor, I would like you to know why we require sensor. Because you are guys already aware of my class, I won't define the definitions at the starting of the session. I will explain the concept with the example. At the end of the examples, you should be in a position to define the definitions. So now let us think about why sensor is required. Because if you understand why the sensor is required, then automatically you will understand the basic definition of the sensor. Now, let us take an example first. Suppose, let me consider example 1 here. So, you and me, most of us came across this kind of situation, like if you are suffering from fever, what we generally do? If we are suffering from fever, our body temperature will get increased, right? Suppose let us take this as you. So if you are suffering from the fever, the body temperature will going to increase, right? So now the question is how we are going to measure this temperature. So what we generally do, even from our childhood onwards, we are much aware of this situation. Whenever we are suffering from the fever, we immediately go to the doctor and the doctor keeps the thermometer in your mouth, right? So what happens in case of thermometer? So let me draw a simple diagram here such that you will easily understand. So how the thermometer looks like? So thermometer consists of glass bulb like this, and this glass bulb, one side it will be almost it is going to be like this. So in this glass bulb, let me try it a bit neatly here. So this is the bottom bulb of the thermometer, and inside the thermometer we all know that we will going to have mercury, right? Like this mercury. So what happens here? On the other side of the glass bulb, this side, we are going to have degree centigrade. So let us consider this as maybe room temperature, maybe like 0 degree centigrade here. And there will be some marking about the temperature here. So maybe it is like 25 degrees centigrade here. And it goes like this. And finally here it might be somewhere here 100 degrees centigrade, right? So now interesting fact is, even if you look at this side of the thermometer here, we will going to have indication in terms of mm. So it might be like 0 mm, and it might be like maybe 25 mm here, and it might be like 100 mm here, right? Now let's look at the example, very simple. Now suppose the moment when this thermometer is inserted in your mouth, what will going to happen? The mercury column will going to rise its height, right? Slowly it will going to increase its height. Earlier it was here. Now slowly the mercury column inside the glass bulb, it will going to increase its length, right? So this is the way how the mercury column will going to rise. Suppose if the mercury column stops exactly here, then we will going to take this reading on the glass bulb, and it might be, if you see this side, it will indicate like 96 degrees centigrade, and if you see this side, it might be at 96 mm, right? So now in this particular example, if you understand clearly, you can notice that the temperature is actually converted into the displacement of the mercury column, right? So temperature is converted into displacement. Let us consider the displacement of the mercury column as x. So that means if the temperature is increased, then the displacement of the mercury column is also getting increased, right? Now let's take one more example here. Now let us look at second example, that is example 2. So in this case, let's consider a simple metal rod. Assume that this is a metal rod. For time being, let's consider that the initial length of the metal rod is L0 here. Now the question is, by chance, if you heat this metal rod with the help of external heat source, if you heat this metal rod, what will going to happen here? Suppose if you heat the metal rod, then the length of the metal rod will going to change, right? So let me keep a heat source here. So if I keep the heat source, let us assume that this particular metal rod is getting heated with the help of heat source. Now if we heat this metal rod, then obviously the length of the metal rod will going to increase. Let us say it is getting increased by an amount of delta L, right? So what does it mean? Suppose if the temperature is at room temperature, then the length of the metal rod is L0. Suppose if we increase the temperature above the room temperature, then delta L also will going to increase. This means that if temperature is equal to room temperature, then length of the metal rod is equal to L0. That means total length of the metal rod is equal to L0. Now, if temperature is more than room temperature, that means it is greater than 25 degrees centigrade, then what will going to happen? The total length of the metal rod will going to be equal to initial length plus some extra length, right? Delta L. So what does it mean? If the temperature is increased, then we can say in this particular example, if the temperature is increased, then change in length of the metal rod also will going to increase, right? Now remember this point. So now let us consider third example here, that is example 3. Again let us consider the situation where we need to measure the temperature. Let me consider a, a simple container here or a vessel. Let's consider that this is a simple container or vessel which is equipped with the gas. Now if it is a container which is equipped with the gas, let's see what will going to happen. Let us consider this as a piston here. Assume that this is a piston, and one end of the piston we have some supporting mechanism here like this. Let's consider like this. Now for time being, let's fill this particular vessel or the container with the gas like this. Assume that these are gas molecules here. Now if I take a heat source here, heat source, let us consider this as a heat source, and if we heat this vessel or container, tell me what will going to happen. Now if we heat this vessel, obviously the gas molecules will going to expand, and when the gas molecules are expanding, then the piston will going to displace in the upward direction, right? So that means if we increase the temperature here now, then the displacement of the piston in upward direction, it will going to increase. Why? Because we all know that when we increase the temperature in the vessel, temperature of the vessel, then naturally the gas gets expanded, and if the gas gets expanded, the piston will going to displace in the upward direction. That means even in this particular case, if you carefully observe, the temperature is converted into the displacement of the piston again, right? So, and one more important thing here is, if we increase the temperature above the normal temperature or the room temperature, then the displacement of the piston also will going to increase. So now if you clearly observe, in the first example as well as temperature is converted into displacement. Now let us come back to the actual discussion here. These are all the three examples. You can understand that the temperature is converted into displacement. Now let me go to the fourth example here. Now let us see fourth example here, that is example 4. So guys, as I said earlier, after discussing all the examples, you will understand the concept of sensors very clearly. Let me take fourth example. You people, you all people might be knowing about thermocouple, right? So what is thermocouple? Suppose if you have some contact here, let us say there is some temperature source here. Assume that the temperature of this point is T. Then these contacts are connected to a metal joint like this. Assume that this is metal A and this is metal B. This is metal A and this is metal B. Altogether, this particular setup is actually called as thermocouple. Now, what happens here is when the thermocouple junction is connected to a particular temperature of a surface, then obviously with the help of Seebeck effect, we are going to get some output voltage here. So now if you look at carefully, what Seebeck effect says is when the temperature of the joint is increased, then the voltage will going to increase. That means in this particular example, we can understand that if the temperature is increased, then automatically the voltage will going to increase. So let me say clearly here, the temperature, if it is increased, then the voltage also will going to increase, right? So that means in this particular example, temperature is converted into voltage, right? So it is a electrical output. Now let's take one more example quickly here, that is example 5. Let me write down example 5 here. Suppose if we take another example, let me consider a semiconductor strip like this. Assume that this is a semiconductor strip of very small thickness. This is a semiconductor strip. So maybe for time being, you can consider that this is a N-type semiconductor strip. N-type semiconductor strip means what? It will going to have so many free electrons like this. So many free electrons will be there. Now, what happens is when you take this semiconductor strip with the help of external heat source, if you increase the temperature of this particular semiconductor strip, let us consider this as a heat source, and we are increasing the temperature of this semiconductor strip. This altogether it is a semiconductor strip. What happens here now? If you increase the temperature of the semiconductor strip, then the mobility of these free electrons will going to increase. That means these electrons will going to run very quickly now. So if these electrons are moving very fast, then what will going to happen? Obviously, the amount of charge which is getting displaced per unit time will be increased. This means that if you increase the temperature in this particular case, then the conductivity of these particular electrons inside this semiconductor material will be increased. So this means the current whatever we are getting at the end, that will get increased. So that means in the fifth example, you can clearly see that when the temperature is increased, the current is increasing. Now we discussed almost 5 examples, right? So in the first example, temperature is converted into displacement. In the second example, temperature is converted into displacement. Again, in the third example, temperature is converted into displacement. In the fourth example, temperature is converted into voltage. And in the fifth example, temperature is converted into current. What you need to understand here is, in all these 5 cases, physical parameter, that is temperature, is converted into either displacement or voltage or current. Now let me conclude the topic here. Yes, now as I said, in the first 3 examples, temperature is converted into displacement. And in the next 2 examples, that is fourth example and fifth example, temperature is converted into electrical output, either it is voltage or current, right? Voltage or current. So what you understood here? First 3 examples, we got the output as mechanical quantity. And in the next 2 examples, we got the output as electrical quantity. Now let's get back to our actual discussion. What happens in these 5 cases is, a physical parameter is converted into either mechanical output or electrical output. This means that sensor is a device which actually converts or senses some physical quantity like temperature. Corresponding to that, it will generate some signal or some output. the output either it might be mechanical or it might be electrical. So that means sensor senses the physical quantity and generates some output or some signal. Sometimes it may be mechanical output, sometimes it may be electrical output. Suppose if the sensor delivers the mechanical output, in that particular case, that particular sensor is actually called as mechanical sensor. Let me write down here clearly, mechanical sensor. So if the sensor generates the output as mechanical quantity, then it is called as mechanical sensor. Now let's come back to the other types. So in the fourth case and fifth case, the output, whatever we are getting, that is electrical form. So now these kind of sensors, again, they are classified into two different types. Either these are clubbed into electrical sensors, or these are also clubbed into electronic sensor. Now you need to know very clearly what is the difference between electrical sensor and electronic sensor. The major difference is very simple actually. In electronic sensors, we are going to use semiconductor materials. That means electronic sensors actually uses semiconductor materials. Let me write down here, semiconductor material. Now in example 5, you might saw that clearly, right? So we are having a semiconductor strip, and when we increase the temperature, the mobility of the electrons gets increased, and as a result, the current flowing in the semiconductor strip also increased. So that means if you use a semiconductor material, then it falls in the category of electronic sensor. And if there is no semiconductor material, but still you are able to generate some output when the temperature is changed, then that particular device is actually called as electrical sensor. Now let me conclude the topic here. By chance, if the output is mechanical, corresponds to physical quantity, then that particular device is called sensor. By chance, if the output is electrical quantity, when the temperature is changing, then it falls in two categories. Either it might be electrical sensor or it might be electronic sensor. So then what is the classical difference between electrical sensor and electronic sensor? Electronic sensor uses a semiconductor material, whereas electrical sensor might not use the semiconductor material. Now let me conclude the definition of sensor here. So from past discussion, by this time you might understood the definition of sensor. So let me write down this point very clearly, and I will be very happy if you people note down this definition. It is a device or an element, or an element which senses physical quantity, like temperature, displacement, or force, or pressure, any physical quantity, and generates some sort of output, generates output quantity, I mean with which you can able to say the value of the physical quantity, output quantity, or else you can say output signal. That's all about the basic idea related to the sensors. Now let's go to the actuators part. Now let us discuss about actuators. As usually, I won't discuss the definition immediately. First, let me explain you the example. Once I explain the example, then automatically you will understand the definition of actuator. So for example, let me consider a motor. In this case, let me consider example 1 here, the electrical motor. So what is electrical motor? So let me draw a simple diagram of electrical motor here. Please consider my limited abilities like artist here. Just try to understand the concept. So we all know that every electrical motor has shaft like this. Let us say this is the shaft which is connected to the motor. Like this, the shaded part is the shaft. And every motor is actually equipped with two electrical lines like this. These two are electrical lines. Now this is the general structure of motor. From the basic physics, we all know that when we apply the electrical input to the motor, that is either voltage or current. If you apply voltage or current, then the motor shaft will going to rotate. So let us say the angular displacement or the rotation of the shaft, let me indicate this as the theta. So that means in this particular example, voltage, whatever we applied, that is successfully converted to angular displacement theta. Now you should also understand one more thing here. By chance, if we connect a screw here at the end of the shaft, what will going to happen? This red color shaded region is screw. So if the shaft rotates by an angular amount of theta, then the screw will going to displace linear amount of x, right? So that means this theta can be converted into linear displacement x, right? So that means altogether we can conclude that electrical input is converted into mechanical output. Electrical input is voltage and mechanical input is either linear displacement or angular displacement. Now let me consider one more example here. Suppose if I take second example here, let me call this as example 2. Let me take a simple hydraulic chamber here, cylindrical chamber, something like this. Assume that this cylindrical chamber consists of a piston. This shaded region is actually nothing but piston here, and other end of the piston, assume that there is a cylindrical rod which is connected to the other end of the piston like this. Now what happens in this particular diagram? If I say this is a port, suppose by chance if I pump the liquid here, assume that if I pump the liquid will going to apply some pressure on the piston. So as we all know that this is piston here. So if the liquid applies some pressure here on the piston, then the piston and cylindrical rod both will going to displace right side by an amount of x units. Right? So that means in this case the pressure, liquid pressure, let me write down here, liquid pressure is converted into liquid pressure. L dot pressure means liquid pressure is converted into linear displacement. And in mechanical engineering, we have so many equipments which can be used to convert this linear displacement into angular displacement. So that means altogether liquid pressure energy is converted into linear displacement or angular displacement. Now similarly, instead of pumping the liquid here, suppose if you use air pressure energy, that means if you pump the air here into the cylindrical chamber, then air will push the piston and cylindrical rod to the right side. Then again we will going to get linear displacement or angular displacement. So now what you understood here, in the first example, voltage, that is electrical input, is converted into mechanical output. In the second example, liquid pressure energy is converted to linear displacement or angular displacement, that is mechanical output. In the third example, that is this is example 3, where air pressure is converted into linear displacement or angular displacement. Now the first actuator, the first device, that is motor, is actually called as electrical actuator. This is actually called as electrical actuator because actuator is a device which generates the mechanical output. This is actually called as electrical actuator. Now these two, that is when we use the liquid pressure, then it is called as a hydraulic actuator. If we use the air pressure, then it is called as a pneumatic actuator. Both of these two are together called as mechanical actuators. Mechanical actuators. Now let me conclude the topic here. Now from the previous discussion, by this time you might understood the basic definition of actuator. What is actuator? It is a device which generates mechanical output. It is a device which generates mechanical output. Again, mechanical output means either it might be a linear displacement or angular displacements. Mechanical output. That's all. Now, how many examples we saw in the previous slide?
We saw three types of examples. That is, first one is motor, which converts electrical input into mechanical output. And then we also discussed about how the hydraulic pressure is converted into linear displacement as well as angular displacement. We also saw that air pressure is also converted into linear displacement as well as angular displacement. So that means, broadly classified, there are two types of actuators. The first type of actuators is
electrical actuators. Electrical actuators in the sense electrical input, that is either voltage or current, is converted into mechanical output, that is either linear displacement or angular displacement. And the mechanical actuators, second category is going to be mechanical actuators. Mechanical actuators in the sense these devices will going to convert either liquid pressure or air pressure back into linear displacement or angular displacement. If the liquid pressure energy is converted into linear displacement or angular displacement, then it is called as hydraulic actuator. And if air pressure is converted into mechanical output, then it is called as pneumatic actuator. So with this, I conclude the topic of actuator. So altogether, in this particular session, I explained the basic concept of sensor as well as the different kind of sensors we are having, and I also explained about the basic concept of actuators and also different kind of actuators. In upcoming sessions, I will explain everything in detailed way. I will also describe every sensor and the mathematical model of each sensor and how that particular sensor is useful in the mechanical engineering as well as electrical engineering and electronics engineering as well as instrumentation engineering. So to understand this concept of sensors and actuators in deeply, so I request you guys to stay with me next couple of sessions. Thank you.